Hello YouTube and thank you for watching. Today I want to talk about indexes that can make a query run slower. In previous session, I had downloaded Stack Overflow database and migrated the data over to Oracle 21c, and I'm querying the table looking for people that have posted the most number of questions. The questions are posted in the posts table with a post type ID equal to 1. And here are the top 10 posters. The query took about 37 seconds to complete. The reason for the slowness is because it's doing a full table access. Let's see if we can create an index to improve this query. So what we're going to do is create an index on the filter column, which is the post type ID. An index is, in a nutshell, a copy of this column in sorted order. Let's go ahead and run the query again. And hopefully it'll run faster than 37 seconds. Already I can see that the query is taking longer. And it completed the query in about 55 seconds, which is way longer than 37 seconds. Let's drop this index and add what's called a covering index. So a covering index essentially is an index that starts with the filter column and includes all the columns that are in the query. Essentially, all the columns that are in the query are included in the index. That's why it's called a covering index. Okay, let's rerun the query again. Now it fetches the results in 1.87 seconds instead of 37.44 seconds. That's about a 15 times improvement. Now, why is it that this query that is on the filter actually runs slower and this covering index runs faster for the same query that is given? Well, in order to explain this, you need to understand some basics of what a database is and how indexes work. So here's a representation of this posts table, and these are the columns that are contained in the query. Now, in order to fetch the requested information, the database has to search all these fields, and the way it does that is to go from left to right, top to bottom. So in the query, if we're interested in all the values where the post type ID equal to 1, what the database has to do is to search through all these fields in order to fetch the requested information. This is called the full table scan, and this is the reason it's taking so long, because if the number of rows is, let's say, 1 billion, it has to search through 1 billion times 8, which is 8 billion, in order to find all the requested information. Now, how does an index work? Well, let's say that for illustration purpose, I have values that are shown here. In order to find all the matching records where post type ID equal to 1, the database has to search through all these fields before it's able to fetch the requested information. What happens if I add an index that is sorted? Now, when the index is available, what the database will do is, rather than searching through the entire table in this manner, it'll look at the index that is sorted and search in this manner. And as you can see, it is far more efficient and much quicker to search the index that is sorted. However, what you'll notice here is that the output is also requesting the owner user ID column, which is not contained in this index. So what the database is doing now is, for every matching record where post type ID equal to 1, it has to go back to the table, search through the records, and fetch the owner user ID where post type ID equal to 1. So the first record, it searches here. Second record, it searches here, in order to fetch the owner user ID column. This is the reason why, in certain cases, using index as only on the filter column can result in query running slower. The second index that was created is called a covering index. And what the covering index does is it includes the column that was in the select query. What we'll do now is drop this index. I will create another index. That now includes the owner user ID column. So this index now includes the post type ID and the owner user ID column. Now if we rerun the query, it'll search through the the first column, finding all the matching records, and it knows to stop here because it knows that it's sorted. And rather than going back to the table to fetch the owner user ID, the user ID column is already included in the index. And as you can see, it doesn't have to go back and forth anymore. Rather, all the requested information is right here in sorted order, so you can quickly gather the requested information and return the results. I hope you found this information useful. If you enjoy the content, please hit the like button and subscribe. Thank you.